Very good morning, everyone. Myself, Dr. Jitendra Mathur, Faculty of Electronics and Communication, TIT Bhopal. So today we will discuss about fundamental concept of first unit from electronic measurement and instrumentation. So what we understand about what is measurement. It is the process by which one quantity for measurement is converted into physical parameters meaningful for numerical numbers. This process is defined as the property of an object or system under consideration is compared to an accepted standard units. We take the SI units basically and MKS units for the measurement. If we want to measure any kind of quantity, they can be like voltage, current, as well as some physical quantities are there in terms of temperature, pressure, humidity, whatever. These all are measured in terms of standard units. If you want to measure temperature, that's why we are using temperature measure, thermometer as a measuring instrument, which can measure a quantity in terms of degree centigrade, degree Fahrenheit. If we want to measure some voltage, then we are using a measuring instruments like voltmeter, and there are the SI units for voltage is volt, millivolt, microvolt. Similarly, we can also measure current and other kind of quantities. So there are some examples we include. If we want to measure a length, then we are using vernier calipers, and for the measurement of diameter of wire by using screw gauge. We can measure length in meter, centimeter, millimeter, and diameter is also. Now we represent a various characteristics of instrument and measuring system. It's showing the performance of instrument to be used. So basically, characteristics of the instrument describe a performance of the instrument, which kind of instrument performing. There are two types of characteristics. With the help of these characteristics, we can represent a behavior of measuring instrument. Such kind of static characteristics is there and dynamic characteristics is there. So what is called static characteristics? So in that case, if we want to observe, if we are observing output voltage, output response with respect to input, if there are the slowly changes with respect to time across the output, so such kind of characteristics is called static characteristics. We are applying some input, and finally we are getting output response, and then we measure the output response across by using various measuring instruments, and after that we show that we are showing slowly variation with respect to time across the output response. So that's kind of characteristics is called static characteristics. For example, we consider accuracy of instrument, linearity, sensitivity, and resolution. Another characteristics called dynamic characteristics. If measurements are concerned with rapidly varying quantity, then comparison between instrument output and ideal output when the input changes with time is defined in terms of dynamic characteristic of the instrument. So there are some example of dynamic characteristics like speed of response, fidelity is there, overshoot, etc. Another characteristics is called precision. It is the degree of exactness for which the instrument is designed. It composed of two characteristics, conformity and significant figures. So how we take the precise value across the output terminals. So that's why we are using some measuring instruments. With the help of measuring instruments, we are taking more than one measured value. So that define the degree of closeness with respect to output in measurement. So now we take the more than one readings. They can be like 2, 3, 4, 5. After that, we are taking average of those readings. Then finally, we are getting more precise value across the true value. So that true value we can obtain after mathematical analysis. So another static characteristics is called sensitivity of instrument. They can also be derived as for the smallest change in the measured variable for which the instrument responds. It is defined in terms of ratio. It is the ratio between change in the output upon change in the input. If we are applying some input across the input changes, we are varying the input voltage, and simultaneously we observe that there is some changes with respect to output. Finally, we are taking ratio between both. So that ratio is defined sensitivity of the instrument. How much instrument is sensitive across the changes with respect to input. What is linearity? It is the characteristics the output is linearly proportional with respect to input. That means if we are applying some input and slowly changing the input across two changes, we are similar changes we observed across the output. So after taking measurement through the instruments, if we are getting similar output with respect to proportionality of input, that called linear behavior of instrument. Right? Such kind of characteristics called linearity of the instrument. So there are some examples like resistance used in a potentiometer should vary. Now another one is resolution. In that case, if input is slowly increased from some non-zero input value to the higher value, it will again be found that output does not change until a certain increment is exceeded. That defines resolution of the instrument. Basically, that represent in terms of threshold value of the instrument. In that case, if we are applying some input like a input voltage is there between 0 to 5 volt DC, and finally we are getting output. So there's a minimum variation is required with respect to input, and we increase the range from 0 to 1 volt, 1 to 2 millivolt, 2 volt. After that, we get the output. There is a minimum value at a minimum measurable input value. At this value, output does not change. Output remains constant. The kind of minimum range is called resolution of the instrument. Another Another characteristic is dynamic response. It is rapidly with which an instrument responds to change in the measured quantity. Fidelity is defined as the ability of the system to reproduce the output in the same from the input. Now we discuss about measuring instruments like DC and AC ammeter. So first we understand what is DC current, what is AC current. DC is called direct current and AC is called alternate current. In case of DC current, we observe variation with respect to amplitude of current across the y-axis. If we are changing time intervals, after that we are getting constant output response across the amplitude of current for a particular time interval with respect to both cycles, positive as well as negative of cycle. This kind of current is called DC current. If we are getting variations, these are basically linear variations with respect to time. We are getting variation across the output current with respect to both cycle, positive as well as negative of cycle. That kind of signal or current is called DC. How we can measure? We are using measuring instrument is called ammeter. These are basically electronic measuring instruments. They can be constructed with the help of analog circuit as well as digital circuit. If we are using EMI coil for the designing of instrument, such kind of instrument is called analog measuring instrument. We can design DC and AC ammeter mainly by using EMI coil. That is called permanent magnet. DC ammeter use current through a moving or a fixed coil to magnetically attracted a ferrous indicator pulling against a centering spring to indicate the strength and the direction of the current flow. AC ammeter can use the force generated by a solenoid that has an aluminum plunger, as it is directly proportionality impaired by the amount of current through in the coil. There is a physical structure of PMMC coil. It constructed inside the coil having various sections, like core is there, and that core is connected with the upper control string and lower control string. So that core is mounted between permanent magnets. There are two poles, north pole and south poles. And pointer is connected with the upper control spring. This is made by soft steel material, and core is generally constructed made by soft iron core. So another moving coil is there. So how we can measure the DC current and AC current with the help of PMMC coil. So there is a pointer. If pointer is deflected on the full scale reading, after observing that deflection, we can measure a value of current and DC current and also AC current. So what mechanism behind that? When current is applied across the core, so some magnetic flux or linkage with respect to core. So magnetic field is created in the direction of in the perpendicular direction of magnetic field. measured, and finally we get the measured value across the AC as well as DC current. Now that working is represented, how such kind of instrument will work. Apart from EMC coil, it is also called the galvanometer, kind of galvanometer that works on the principle of DSO. These instruments use permanent magnet to create a stationary magnetic field in the coils, and that it is used with the moving coil that is connected to the electric source for generating deflection or damage left and right. After that, the magnetic field will be in the forefinger. Flow of current will be across the middle finger, and finally, force will be through something. These are the circuit diagram of DC and AC ammeter. In next class, we will discuss about working principle of DC voltmeter with